Cool. I guess we'll just wait for a minute or two for letting everybody else also get started. First of all, super excited to have you guys here. And it's really interesting. Now LinkedIn has added this feature to schedule the live workshops. I know it's today there is not a single solution in the world that can cater to how how we go online and how we work. But what I like is that um, LinkedIn added this feature. You could put up a live workshop a week in advance. So this is great, and I can see it here as well on my phone. It goes literally on my profile, and it says on top of my profile that I'm live, which is actually very useful. So good job, LinkedIn. You did a wonderful job. I think you learned. And here I can see that I'm streaming, which is great. And I can see how the transition is going, because there's a small lag. But again, I mean, this is technicalities. So I'm super excited to have all of you guys here on this workshop, which we're going to be giving. I'll be giving on. Hey, Naresh. Yes, I'm happy to be back. Just trying to share a couple of interesting things. I'll give you all a bit of an update also on a group of companies that we are running and how that's going in the end of the workshop, because machine learning operations is the core of everything that we're doing. So that really makes a lot of sense. And I can see that the presentation is live. So let's not waste too much time. I know your time is valuable, and I respect that. So I will spend about 30 to 35 minutes, and then I want to take questions from all of you. And I look forward to sort of having an interactive conversation. So if you have any questions, I can read your comments and I can answer your comments. Just keep asking questions. I'm not the kind of presenter who likes to shut down and complete his talk and then go for Q&A. So keep adding your questions here. I will do my best to the best of my knowledge to answer them. The ones that I cannot, I will obviously continue to answer as the feed concludes. So a bit of housekeeping. Another small thing I need to do is get a glass of water, because I know if I talk a lot, I tend to start struggling with my throat, and we don't want that. So orange juice. So I guess let's get started. Cool. So machine learning operations. I mean, what is MLOps, right? I mean, so basically, I'll just sort of now focus on my PowerPoint. So basically, MLOps is something, it's born out of the concept of DevOps. So it's a kind of a set of practices that combines the software development and IT operations together. And this is probably the most important thing that is defining this whole sort of revolution that is happening in machine learning landscape. So the last couple of years, there's been a lot of work done, and it is continuing as well in the field of the AI research, machine learning research. But you're seeing increasingly that there is a move to take these research applications, apply and create wonderful models and solutions, and they eventually push them towards production. So just one statistic for you guys to kind of also take a think with me is just 1% of the world's computing workloads are actually in public cloud platforms like Google, Amazon. I mean, enterprise workloads, right? And out of that, the reason why it's not happening, and however, there are so many tools out there in the market, it's not happening because of apprehension, data security, data safety, etc., but also because there is not much, not much focus has been laid on taking these great research models and solutions into production. Fortunately, last year in 2020, when I say people, all the startups which you see around yourself, Weights and Biases, and a couple of new startups that are out there. So experimentation startups, startups doing all kinds of things. I will take a look at that. They've raised close to a little more than 100 million. So you might say, wow, that's a huge amount, but actually that's a really low amount, which is sad, because many other startups are raising a lot of money. So in a way, MLOps revolution, as much as there's a lot of excitement around it, it still is going rather slow. So you see there are 63 slides, but we're just going to cover like 10, 20 to just give you a bit of a sort of a brief makeup of what we're doing. So let's get started. So MLOps or MLOps, if you don't do things well. So let's take a look and see if, yes, all right. So this is me. My name is Terry. I am co-founder and CEO of DeepKaffa.ai, which is a research lab. Real AI Incorporated, or Real AI BV, as we call it in Dutch, is a company that focuses on bringing research ideas into production. And we use all kinds of platforms and tools and methodologies to do that. Then we have Kurai, that's a healthcare startup with which we're doing some interesting things. And I'm also co-founder of Live AI, which is the education startup, which is where we try to also bring our experience and our learnings to the market. So just a bit of a very quick sort of introduction. So the ecosystem in AI is definitely transforming. Let's sort of try to think about it. What do I mean by that? So my sort of argument, and I think there are many people who already agree also to this argument, is that AI has become software and is empowering the way software is going to be developed going forward. The reason why I say this is there's going to be a lot of development where, mom and pop shops, people with basic backgrounds, who don't need to understand all the depths of programming, understanding how JavaScript works or other programming languages, can now jump up and use low code or no code tools and techniques to actually start pushing their products and solutions to the market. I don't know. There's one of you is saying you're not able to view. I hope, I don't know if anyone is having trouble with viewing the video. Someone's shared in the group. Just raise your hands or just a handful of people if you can say that you cannot see. I can see this, by the way. So I'll continue to keep an eye on it. So thanks. Probably it's your local internet issues, but sort of, yeah, just kind of take a look at what's going on. So hi, Dharmendra. Hi, Raghu Prasad. I'll answer the question. Keep adding the questions. Very good, very good. So, all right. So AI is software 2.0. And why, if you take a look at this, so you have, if you look at this revolution that is happening from the 1970s all the way till where we are today, and we're just at the beginning, as you can see here in 2020, this is a slide extract I took from ARK Invest, who work with a lot of interesting startups and ideas. And software used to be written by humans or people like you and I, software developers. And it started off with companies like Microsoft, Oracle. Back in the 70s, Microsoft was born in 1975, and Apple went into also a bit of software development. Oracle and SAP did a lot of middleware software development and created large enterprise products. So today, what you're seeing is that this space of a capability of software in terms of what software can do, and the variety and the need of where software can go, not just in enterprises, but also set up a small model for your shop in which you have customers, just a retail shop or pizza store or some local shop. You could actually apply software, and people started doing that already. So one simple example of a low-code platform was WordPress, right? It started off as an ugly blogging platform, just like Google had its own blogger. And WordPress since then has become a platform where people do a lot of work and just plug and play and add widgets. It's not the best of the sort of way to kind of plug and create your platform or website together, but that's one of the examples. Now, what's going to happen from 2020 to the coming 10 years onwards is code is going to be written by data. So code used to be written by humans, and now since there's so much data, so much intelligence, everybody is online. People are going to be using the intelligence that is derived from data. And if you're a machine learning or a deep learning expert or enthusiast, you know what I mean, right? So you have these language models today that are doing a wonderful job in creating example sort of tools to complete your sentence, create a wonderful legal text as well, if you will. And it is all happening because software developers are just using APIs from platforms like OpenAI or Google's BERT or some other new emerging platforms in order to make this happen. So that's what's happening, and I'll try to kind of keep up the pace. I realize I already spent 15 minutes just a handful of beginning first slides. So why is it happening? All right. So 2020 to 2030, the growth is fueled by AI because of the high performance computing. You all saw NVIDIA's keynote, right? It's probably still going on today, if not, the last 2-3 days have been very fascinating. Jensen Huang also went online to talk about their new CPU that they have invented called Grace, which is based on ARM. So all these things, scientific computing and scientific supercomputing used to be a totally different field. It's been going on for a long time, but it required tons and tons of capital to actually invest and create these huge simulations, whether you're doing atomic simulations, trying to understand and solve a disease. And it used to take a lot of time as well. So it used to take understanding used to take a lot of time, and to do those computations and simulations used to take sort of literally a lot of time. It used to be multi-year projects and sequential. You couldn't do parallel computing because there were no tools out there that could allow you to do parallel computations. Commercial computing and scientific computing has kind of come together. 2010 saw the birth of cloud computing. 2020 is going to start seeing that the AI, or the jargon, but machine learning and deep learning workloads will be super exciting for the world to use. And you will see increasingly that this will fuel the software revolution. And this is where most of the action is going to happen. So just to give you a bit of a more perspective, so you get a sort of a grip of what I actually mean. So this was a research done by Battery Ventures. It's a venture capital firm. And they said, okay, the global software industry has not still reached its maximum potential. So if you look for just to look at the next sort of 10 to 20 years, we are today in close to $1 trillion, or maybe a little bit over $1 trillion at 2020, and you can see by 2030, by 2040, you're going to start seeing $2 to $3 trillion, which is dramatic. I mean, just software industry. I mean, today the whole IT industry comprises of, I think, $3.8 trillion. And if you just see software that is going actually at a dramatic rate, with compound sort of a growth rate of 5%, which is pretty dramatic. And software revolution is just barely begun. That's what we're trying to say here. So just to give you a bit of a numbers, give you a bit of an idea. So about 1.1 trillion sort of dollars of investments are indirect, and close to $500 billion. This is just U.S. Is coming is added to the U.S. GDP market, and 63 billion, a little over 63 billion of R&D investments are just made by software companies. Think of Apple, Google, all these companies, but also all other companies in China, in Europe, and elsewhere. So, and this number is rising. And finally, the most important thing is, how does it matter, all these big numbers? As much as there's a lot of confusion today in the market, I do believe that the job market is going to be dramatically increasing. So this is why you see all these e-learning platforms coming up. There's a reason why they are there in the market today. The thing is, the need, in order to serve that large market that is coming, the need will be for people like you and I, but also people who probably may not have had sort of intense experience in software development. People from the 80s and the 90s and the 2000s did different things to do software development. And now people will just pick up tools and just bring and build and knit things together. And eventually they're pushing these their software, and also elegant and pretty, a great user interface and great user experience. Just plug and play with these platforms today. And this is why you need to be prepared to actually start learning these new tools and techniques. And I'll talk about a few tools. I know there's not always enough time. And that's why you have to keep focus on not just the traditional software development techniques, but also the emerging techniques of low code. And no code is a huge new world that's going to emerge in the next 5 to 10 years, where speech, things that I'm doing right now, can be converted into a beautiful website. I would just, after, for example, very simple example, just a startup idea. So I'm doing this online live session with you guys. Now it takes me 50 different steps to actually make this Power PDF ready. So a lot of people will ask me, hey, give me the PDF, Terry. Okay, so I'll go and save the PDF. Where is that PDF? I cannot download it. Oh, there's concurrency problems, and I share it somewhere online. Now, if I were to just use a voice command to start up a service that'll set up a simple sort of a page, a web page, call it a landing page, having all the narratives, even taking the quotations of what were the top things Terry said, make a website, and suddenly, boom, it's out there. It can already happen. Speech recognition and speech sort of the things that I'm doing with speech now can be also be super interesting, because you can see when was Terry excited, how much time did he spend on one slide versus the other? Okay, that's a way for me to be performing well. But all these things are coming online, which is super fascinating. But again, that's why these millions of jobs that are coming towards us, we need to fulfill and we need to add value to these jobs. And that's why it's very important for us to stay up to date. Okay, let's go into AI, because that's why you guys are here. So artificial intelligence is also going to be going dramatically. As you can see here on the left, pre-AI era used to be, industry penetration was low, companies were not doing much, and if you look at the compute time, was also there was not much compute time happening in terms of, if you look at the Y versus the X-axis. Computer vision actually came into sort of prominence in 2015, and now we are living in this age of language models. So I mentioned a few terms which might sound cryptic to a few, for example, GPT-3 and a bunch of other new models. But language understanding and natural language processing is going to be a fascinating new market that is going to lead to all these wonderful, wonderful applications. This slide deck, by the way, has a few examples, so you can take a look at it. I won't go into it because we don't have much time. And the thing is, a lot of people are still sort of experimenting and working on reinforcement learning, an advanced field of machine learning. But that is also going to pay off dramatically in many, many ways, in robotics and a bunch of other sort of areas. Companies like DeepMind, which is parent company Google, or Alphabet, I should say, are doing a lot of work there as well. So this gives you a bit of a perspective. Now, commercially, in terms of numbers, what does that mean? The market that was created, and this is from ARK Invest. So the market that was created by internet economy, right? So 1995, internet came into existence, and fast forward today, so 20 years, 2020, 22 years, um, it created about a $13 trillion worth of economy. And AI is slowly becoming sort of, or deep learning is becoming super interesting. But people estimate that in the next 70 to 20 years, it's going to create almost 3 times more value. So these are the numbers in terms of jobs that are going to be created for a lot of folks, younger folks today who are in their teens, people who are in undergraduates, but also professionals who are in their mid 30s and even 40s. I would say, there's no end and there's no sort of limit to learning and doing wonderful things with your career. So I really think these are dramatic sort of huge growth numbers that will lead us to hopefully forget this corona that we are in today and start moving and building a career. So this is very important for you guys to know. All right, so let's move on next because give you a bit of a perspective. Now the state of AI. All right, you guys just watched NVIDIA's GTC summit. So they're talking about SuperPod. We were having an internal discussion around the Megatron Triton. A lot of these massive models are coming together for you to do these things, the things that I just mentioned, be able to do wonderful work and create elegant and pretty applications for your consumers, be it your local drugstore, be it sort of a platform in which you're using to serve your customers in a region or international. It's all in your hands. But how do we need to sort of go about this? We need to understand a little bit how sort of this revolution happened. So I'll just go very briefly, and this slide will be available for you guys. So just go quickly, step by step. So 1990s to 2000, the way we used to do things was you had a physical server, you had an operating system, you had a CD and floppies. I'm sure a lot of you wouldn't know what that means even. And you had an application, and that was it. The machine couldn't do anything anymore. In 2000 to 2008, we saw application clusters, emerging where you were plugging up machines together with cables, Ethernet cables with 100 Mbits was used to be already fascinating. I remember it was exciting. And the first time I got my hands on a Cat 5e, that's a category Ethernet cable that allows you to do a gigabyte, computer-to-computer communication. That was fascinating. But still, that allowed us to build clusters, meaning you had application clusters, you had middleware clusters, meaning application is where your software is developed and you have your Java or all the other platforms with which you serve your customers. Middleware is where you have your databases and all these other, or business logic, actually. And then backend is where you have your databases, so sort of secure platform. But anyways, so 2008 to 2000 to 2008 was still building clusters with physical machines. And then you see these green boxes. I just kind of made a bit of a distinction that these are sort of, think of them as virtualization. So virtualization is becoming hot. It is also the foundational block of cloud computing, for those who don't know. There's a lot of virtual sort of platforms, virtual machines, very thin machines sitting on hypervisor that are doing this. Awesome. So basically, 2000 to 2015, like I mentioned, computer vision was still getting sort of started, and this is where infrastructures were still managing workloads that were not doing anything with AI. And today, what you see here is that, fast forward today to 2015, you have a lot of on-premise, hybrid, and also public cloud environments where you have virtual clusters and virtual infrastructures, and they allow you to sort of have few large physical machines, and you put virtual machines on top of them. and you can add all your sort of application servers, middleware servers, database servers, marketing, or any other little servers. You can just fire them up with a snap of a finger, because you don't need to talk to 20 people networking hardware. So things are moving in the right direction, but still, as you can see, just 3%. I think I said 1% at the beginning. That's incorrect. 3%, and this is Gartner number, by the way. So 3% of the companies still do not go to cloud, and especially enterprise companies, for reasons we can understand, that you want reliability, security, and you don't want outages and all the other problems to disrupt your business. But in any case, the reality today is, whether cloud computing or public cloud and infrastructures like Google or Amazon or Microsoft Azure or Alibaba, Huawei, and all the other platforms, or you do it on premise, it takes a lot of effort to do it. Now, the reason why things tend to look inexpensive on the cloud is because they have large data centers where they have millions and millions of servers in their data center, so it's easy for them to serve and service your workloads. Anyways, this was the pre-AI world. Now we are in the post-AI world. So what does the post-AI world looks like? And as you can see here, the AI accelerators, which is what you hear a lot of companies like NVIDIA and other chip manufacturers talk about, is it's all about acceleration of AI workloads, if you will. And acceleration, it's cheap. CPU is very sequential, and computations happen sequentially, which is fine for simple applications. But if you're doing matrix multiplications, which is what tends to constitute to what you do inside your machine learning or deep learning applications, you require probably thousands of cores, maybe even tens of thousands of cores if you have a large application in a GPU or even a tensor processing unit or other forms of hardware accelerators. And this is what actually charged the revolution. So here, as you can see here on this slide, I'm showing from 2016 to 2018. Things were still getting experimental. People were playing around. Researchers were playing. We were playing. I was playing with these kind of workloads. Simple, have a physical machine, set it all up. I can have an operating system on top of operating system. I put Dockers, or Kubernetes didn't exist back then. But trying to work with these container architectures, which is kind of similar to virtual machines, by the way. It's not rocket science. It's just sort of containerized differently. It doesn't encapsulate everything which you need for an operating system. That was a logic. But again, I'm not going to go into the difference between containers and physical machines. That's probably a different lecture altogether. So 2018 to 2020, then you saw the similar kind of people were thinking in terms of, how do I crunch and run my AI workloads? That's probably the most important thing. We've also participated in building and working around with clusters, although not large, but still large enough to do crunch, pretty interesting workloads. And still, it was not that difficult. So you see that, that little sort of ring is where MLOps comes in, and I've kind of painted it as red. But essentially, there was not much sort of idea. So people knew, everybody knows how to sort of, take ideas from development to acceptance, or development to testing, testing to acceptance, acceptance to production. But there were no sort of methodologies around. People were not able to understand, how do I sort of work with these dynamic workloads, and what do I do actually to serve these workloads? It's not just left to right, that, okay, it's ready, so let's take it into production. It's basically left to right, and then right to left, and then it keeps moving back and forth. So this is where sort of, what you're seeing today is, so I've just put it in 2020 to 2023. Probably, virtual machines are getting also, or containers are getting easier to manage these days. But still, you will see many of these workloads now putting in GPU coming to the game, including all the CPU, disk, memory, and your networking, et cetera, is becoming already virtualized. Now, GPU is going to be virtualized as well, is virtualized already. When you work on, let's say, Google's Colab, you're actually using a slice of a GPU through, so you're doing a hyperpass, is essentially just using a small part of that physical GPU, which is made available to you. So it's just not the 11 gig that you get. It's just much less, I guess. And essentially, that you see here on the absolute right is where large companies and large science labs and lots of other sort of organizations are using these multi-cluster, multi GPU and large GPUs, like let's say 800 from NVIDIA, and all other families to really put massive compute capacity inside these workloads. So this is how the post AI world is going to look like. I think it's going to look like, but what's happening is, as much as we see and we need MLOps is going to be super complicated because, as you can see here, it's a need out here. So if you can see here, and I will share this again, this deck with you guys. So MLOps is a field in which a lot of new things are emerging. So essentially, remember when I said scientific computing, and then you had commercial computing. In commercial computing, does not really focus on making experimentation and testing and research and development part of their core business. I mean, it is for many companies like Procter and Gamble, or even your smaller company which focuses on research. It is core business, it's important business, but still their core business is serving their customers. Now, what is happening is production environments are being flooded with all these platforms, and essentially these machine learning platforms. And to understand how to serve these workloads, to understand how to tune these workloads, to understand how to do continuous integration, continuous development of these workloads, things are becoming extremely complicated for a lot of people. And this is why you're seeing the MLOps ecosystem is exploding, literally. So here, I've just sort of put up a bunch of companies, or probably 100 or maybe more, and I've done my best to try to include all of these companies. If you are a startup and your company isn't in here, do reach out to me. I'll add this to my deck. But you get the idea. So data management, data visualization, model lifecycle management, workflow analysis, debugging, standardization. Explainable AI is a sad little entry here at the bottom left, because it's not getting much traction. So there's a lot of traction on end-to-end platforms. Companies like Data-IQ, Data Robot, a couple of guys, and Amazon's SageMaker, and Databricks, probably leading the pack right now with raising $1 billion worth of investment, which is fascinating, I think, for Databricks, and great for the industry, for all of us. I think it's a great validation. But still, I'm concerned that it's going to be a bit of a challenge for enterprises, especially enterprises are the ones who are buying the software from you, and that'll be a bit of a problem. Because as you see huge competition, just look at the MLOps platform and tools. There are probably, I don't know, 15, 20, or maybe 30 companies already out there. It becomes very difficult for me when I work with our customers and enterprise customers to talk about any of these companies, because I have no idea where they are in the journey. I mean, I've heard of them. For example, Algorithmia is a company I know for a couple of years already, from 2015, 2014, 2015. They've been doing and building a lot of stuff. Now, what do they include inside the MLOps versus what do they not include in the MLOps? Meaning, do they do AutoML? How good are they with data exploration? How much of experimentation is possible with the tool? And is it end to end? That's probably the most important thing, because this is what the CTOs and the CIOs and even chief executive officers who I work with ask me. He says, okay, fine, Terry, I don't want to spend my time and money in startups that do just part of sort of this whole puzzle. But anyways, so the MLOps ecosystem is actually growing uncontrollably. But like I said, MLOps, doing all kinds of things, experimentation here, deployment there, or testing here, debugging here, and all that stuff. It is all about great deployment. That's what it's all about. And I think we're going to spend a few minutes, maybe 10 minutes. I'm just maybe quickly take a look at if you have also been asking questions, because that's where I should be focusing on as well. All right, I have these questions. Wonderful. I will answer all these questions. Thank you so much. Great. So Toma, you have a question. Great, thank you very much. I'm glad that you confirmed that. Dilip, Michael, Purushottam, and Steve Fisher. I will answer your questions. Some of you have comments. Great. So wonderful. Let's get back. So it's all about deployment. And once again, so MLOps is different strokes. I showed you like 50 strokes, right? One is a hero in experimentation, but the question is, okay, fine, but are we going to deploy it someday, or are we just going to be playing around in experimentation field? So you can do different things, and there are ways to deploy these with, put up all the, stuff together, plug it up in, and build them all in containers, and then essentially start, shipping these into on-premise or into cloud computing environments. But essentially, it is all pushing these into production. So basically, that's what I mean. So how do you take your AI workloads into production? So here is the ML lifecycle. I picked up this picture. I think it's kind of represents reasonably of what MLOps is and what MLOps should be. And you can see here, so essentially, they're all cross-cutting projects. MLOps have actually touched literally virtually every domain inside your company. And this is why it's very important to understand how to bring these various competencies together in order to successfully do my MLOps project, or call it your AI project or machine learning project, whatever. So essentially, as you can see here, so there are pre-project activities. So you need to definitely make sure, and we do this literally step by step in our teams when we're working with our enterprise customers, large or small. We make sure that each customer is going through this education cycle and understanding layer by layer, what do we need to do to set things up in order to not miss the boat? And then what do we need to do in terms of doing data ops? And I'll sort of, that's collecting data, labeling, that whole data ops activity that needs to happen. And then comes the part where most of us tend to be focused. All the memes that we share and all the fun stuff is all about training and debugging, and potentially maybe even deployment. But then the core part is, choosing a simple model, implementing it, debugging it, and doing all kinds of various runs, essentially parallel runs to train, validate, and test. And then essentially prioritizing improvement is what that means here, is making sure that how do I take the best models, continuously integrating and continuously deploying these inside my production, which is where you have pilots. You will do testing, so you have all kinds of testing. We'll test a few forms of testing, and then and deployment essentially. And then you have the CI, so continuous integration. Then you have CD, continuous delivery, and then you have CM, continuous monitoring. And you would say, hey, well, what do you mean continuous monitoring? Obviously, you need to automate that process as well, because continuous. It's not like database or applications that are kind of static, right? Database is tabular. Sometimes I have a lot of customers, sometimes I don't have too many, but essentially they all come and fill into the tables that I have, right, inside the rows. So there are no disruptive activities happening. But in a machine learning model, things change dramatically. There are things like your model drifts, meaning it's not as valuable anymore due to some form of ingestion issues. You're sort of acquiring poor quality data, or you're acquiring totally a new family of data, which allows your model to start saying, okay, there's a new feature in town, or what do I do? So this is how the end-to-end sort of life cycle looks like. And remember, I was just mentioning about research and production. These are two different fields. So machine learning is essentially, for a lot of companies, for every company, and I think it should be, and it is, and it has to be an inherent part of your machine learning practice inside your companies. Research should be a core part of it for your service inside your company. But ensure and make sure that when you are going from models thinking into systems thinking, that's a huge shift, because you need to have these couple of principles as I picked up from internet. But again, I mean, they do represent these values of how things are treated in production-grade systems. For example, they're reproducible. You have to have reproducible workloads. You cannot work with experimentation and take that to production, obviously. I think we all understand that. So you should be able to replicate and explain and interpret. This is where you can put body, you can give hands and feet to your explainable AI solutions. Today, explainable AI is just probably, for some it's a controversial issue, for others it's a theoretical or a regulatory issue. But I think it should become a technology implementation inside of companies. That's what I mean. And we should be able to automate these things. When you go into systems thinking, your systems cannot have 50 people walking around doing all kinds of changes. It'll fall, it'll collapse. So you have to iterate the loop of training, deploying, and updating the models automatically. It should be extensible. It should be, you can easily add and update models. It should not just allow you to say, okay, okay, there's this new model coming in. So we are working with computer vision models, and now we have language because we want to start providing all kinds of automated, maybe tagging, or maybe some other kind of advice to, let's say, medical image, something else. You should have pipelines ready. Fortunately, there are many tools out there to do that. I cannot, unfortunately, go into that because each industry domain requires a different sort of explanation. But extensible is super important. It should be modular. It should allow you to pre-process and feature engineer code and in clear pipelines, so you can kind of make sure that your multiple pipelines are working and efficiently. Scalability is super important. Testing in isolation versus putting in production hands of real-world users and enterprise clients is very, very different. You definitely need to have that. It should be testable, or you should do rigorous testing. So testing is seen as a boring topic for a lot of people, but it's a very important art of continuous integration and continuous deployment. Without testing, your model actually should not be allowed to go into production. And this is where researchers and engineers and young people say, oh, right, I spend 85% of my time testing, and I'm waiting 6 months. I can do, in 6 days, I can create a model, and it'll take me 6 months to deploy it into production. And this is a true story. Happens a lot to a lot of people. So this is a wonderful example I took from ThoughtWorks, and Jez Humble and Dave Farley. They've also written a wonderful book on continuous integration. It's like 10 years ago or 15 years ago. But understanding from the principles of what are the things that actually make machine learning, right? So the things that, as you can see here, data, and then having, how do I understand data? And, schema sort of architectures is, typical to how we treat databases. But this is very different. I mean, you saw data lakes and all the other big data sort of revolution happening. You have your models, which is, it was great when it was done in isolation 20, 30 years ago by scientists. They had simple models, did some simple regression. Maybe some guys even experimented and worked with support vector machines. But eventually that was it. People were not thinking of, well, this will be used and served and yelled at and be the core of my company's business. Today, it has become that. Software development, well, business needs, understanding how the user interface, user experience should look like, bug fixes, etc., is super important. But again, so continuous delivery for machine learning, I'll just read it for you. It's a very important and interesting quote that these gentlemen sort of have sort of put up on their website. And it's also a wonderful book out there, Continuous Integration, Continuous Delivery. You should definitely buy that book. It's 10 years old, but wonderful book. So it's basically software engineering in which cross-functional teams produce machine learning applications based on code, data, and models in a small and safe increments. So basically build by brick, brick by brick, brick by brick, a block, and then modularly sort of building it up. And then essentially you can reproduce and release it reliably in the production. This is how you release actually value when you talk about value creation, the machine learning applications. So great, I'll sort of go a little bit fast. I hope you're still enjoying. I see there are quite a number of people online, so I'm grateful that you're still able to sort of hold on. I'm very thankful for that. So getting stuff into production is looks like this, right? I know a lot of you guys are posting wonderful applications you're deploying in Heroku or Netlify, Streamlit, etc. Looks wonderful, or maybe making your own beautiful implementations on D3.js or some other beautiful visualization. But the thing is, unfortunately, it's great, and it gives you a feeling that you have your training data, you've got labeled data, you do your model building, you built your model, you come up with a simple web app code, you push that your data, you're finding into a JSON file format or maybe XML. I don't know if people still use that. And then essentially deploy it into a wonderful looking interface, and voila, I am in production. So it looks easy because it's become easier for you to do that with PaaS or platform as a service platforms, but it's not that easy. And this actually picture I took from introductory book by data-decay is very actually defining, because this is how you tend to realize that it's important for you to be part of this family or be part of the village. So, like people say in English, it takes a village to raise a child. I would argue that it takes a village or a company to actually serve an ML model. So basically, from doing things on your own in isolation, where you can do a lot of things, you have to understand that in order to automate, you have to gain and automate and deploy. You have to gain trust and earn a trust within your different departments. For example, you have your business questions. So you need to make sure that subject matter experts and the people in the line of business are still are the key sort of stakeholders, because they are the ones who are telling you what needs to be done in order to make this application land and essentially expand inside their infrastructure. Sales, marketing, risk management, R&D, warehousing. People with their different business problems, they know exactly what they want. So very important to work with them. Communication is key, extremely important. So if you don't communicate, you will not be able to build automated solutions, because it'll be very frustrating for you. So keep asking, keep improving your model and also your deployment strategies. Make sure that you are thinking end to end, because if you do not, then you will run into problems. And that's why you have this team. If you're working for a large company, you will have these benefits. And then essentially prioritizing continuous delivery and delivering your apps with great quality is what makes you actually essentially a machine learning expert in the real world, right? So it's very different than isolated experiments and probably doing all other things, which definitely are all wonderful, whether you're training and learning on Kaggle competitions. Essentially, all those wisdoms come together when you start working inside enterprises, because that's when you become a real-world expert. So as you can see here, this is a sort of an organization structure of how data engineers, data DevOps engineers, people specifically with DevOps, have their own specific capabilities. And I won't go into deep into these, but you get an idea. So essentially, what you're looking at is just develop models. What you can see here, it's just one part of the equation. So you have business questions. You need to understand what does it mean to actually prepare. And this is where testing comes into a huge sort of play. And then essentially acceptation or acceptance from your end users, and doing sort of slicing a small group of users to actually accept is a function acceptance. Very different sort of principles, which if you haven't worked in enterprises, you will get used to these. Is very important. And then essentially, when you go into a production, so as you can see here, elastic scaling, containerization, continuous integration, continuous deployment, and then I guess CM is on the left, on the right here, logging, input drifting, so input drift tracking, model drift, a model shift, how models changes based on the new features that come in. And essentially online evaluation all become very important part of your system. It's not anymore an isolated sort of wonder child or a wunderkind. It becomes something that has to live inside this village, inside this production platform. I think this is probably the most important thing I have learned. And each time there is this new revolution, as much as I'm super excited and fascinated with AI where we are today, it's still early days. It took 10, 15 years for people to start reliably trusting cloud computing environments, and still you see just 3% of enterprises want to put their workloads on the cloud computing. In order to build trust and expand our trust within our stakeholders, helping even startups. We work with startups, for example, experimentation startups like Neptune. I work closely with the CEO and a lot of other startups. No need to sort of mention names. But we work very closely with these companies, but also large companies like Microsoft and Google at the core to keep building awareness. because awareness is the most important key. However soft and boring it sounds, it's probably the most important thing, because it's essentially, I have very selfish goals. I don't want to do 6 weeks of building a model and waiting 6 months to deploy. I want to do it in 6 weeks, maybe even less. 6 weeks build, 6 weeks deploy, and then continue to keep improving my applications. So my business continues to start adding more features, and then this application becomes profitable, it becomes a successful story. And that's what I have done in the past, and I know what the benefits are. Can give huge, interesting, and exciting snowball effect. Awesome. So machine learning pipelines, this is how it looks. So you saw it's in simplistically, again, I'm just trying to make it very simplistic here. So you're training data, you have different skill sets. Data scientists are training, model training, and building models. Data engineers, do a lot of work, actually. It's not just labeling data. There's a ton of work that goes into that. And then you have deployment. So people have this rough sort of a division between ML engineer, developers, and what are the skills that I need. But essentially, taking the app, building the app, and then understanding how I have to understand from the deployment and monitoring perspective is where it makes you a great machine learning engineer versus someone who still needs to learn and become great. So that's the small difference. And as you can see here schematically, I think this is an example from MLflow, very simple example. Oh no, this is a DVC example from their website, from ThoughtWorks, wonderful sort of article out there. So you can see here data ingestion, and then essentially, what are all the activities that happen on your left, which is your data. So downloading data sounds, simple, but there's a lot of pre-processing happening out there. And I know when we do our projects, all kinds of things of, looking at various aspects of data, understanding data, whether image or text, but even digitizing sometimes can be a real pain. So it's a huge activity happening in the section 1, and section 2 is also a tremendous activity of rinse, repeat, build, experiment, add new features, play around with hyperparameters, etc. And then you have on the right, very simple structure, the way I've sort of described it, but eventually in the end, you're building a model. A model is essentially a model file that has stored sort of weights, essentially, or the features, how you would represent them in a graphical user interface, how actually it serves your customers. So basically, essentially, a model is at the back, and then you have your apps, and things like Face App or any other, or for example, your facial recognition or an Apple. All this work is happening at the back end to make sure that you have instantaneous sort of response. And I'll show you a table to give you a bit of understanding of how quick and dirty and sort of on the fly serving versus data streaming, all these things happen, because those are different things. So ideally, a tool should have at least these basic functions. You should be able to allow multiple backend sort of plugins, so that helps you sort of fetch and store large files and external storage. Keeping a track of file version, data versioning, data registries is super important. So you can essentially keep a track of what are the models that are actually fresh, right? Versus the ones where there has been a data drift and they have shifted as well. And essentially, you also keep a track of the dependency graph. So what you're doing is you're executing your ML pipeline. You're allowing processes to be reproduced in other environments. That's why you need the dependency graph. You should be able to integrate with Git. People use Git as well. GitHub and Git essentially is becoming also a very interesting tool. So this is an example. For example, there are companies. This was an example from DVC. So a data science version control a tool, which was also mentioned in my MLflow MLOps infographic. And then you have Pachyderm that solve different problems. But essentially, the goal is to have these basic principles to get you started. But there are more advanced tools that do more interesting things, like hyperparameter sweep, things like that. For example, weights and biases does that, which is also cool. But there are other platforms. There are a ton of platforms. So basically, you have to understand what are the fundamentals that I need, and essentially, how do I build these? And in my MLOps course, by the way, which I'm going to be delivering in the next 2 weeks, you will see that I will help you learn about each and every aspect. Model registry, how to do that, deployment, how to push it into IaaS, how to push it into PaaS. Those kind of things are very important, right? Awesome. So here you have, there's a lot more, as you can see here. So it was not just a simple deployment. So here you can see here is that experimentation. So if you look at the right side of the green sort of cubes, you have a lot of other aspects that allow you to understand. Well, there's more to MLOps than sees the eye. So experimentation, there are a bunch of tools. You should be able to do end-to-end testing. There are different sort of methodologies in order to do that. You can, and differential testing is also super important for you to understand. So basically what differential testing means is, so it's like a test that compares the difference in execution from one system version to the next when the inputs are actually the same. So that is what the differential testing is. So it's basically also sometimes called back-to-back testing. And it's very useful in detecting actually machine learning systems errors, actually. So, and that's where, and without any exception. So that's very important for you to understand. There is this concept also for contract tests. So I won't go deep into all these, and do take a look at. I think I provided a link here at the bottom. Do take a look. Contract testing. So these guys have they talk about testing test double. So especially this is needed when you're specifically focused and working with external service. So then you can add contract testing as well. And so basically what happens is test double is super handy because it stops your own test from being slow and unreliable. If you have as you can see here in the picture as well, when you have a remote service and you need to basically be able to have accurate representation from the external service. And this is where you do contract testing, but I won't go into detail. This is a separate sort of field. And then you look at these three sort of vertical cubes. So as you can see here, data pipeline, data validation, and then I'm calling it DUT, or data unit testing. And then essentially you have ML pipeline, and then model validation and MUT, or sort of ML unit testing. And then you have your UI UX pipeline, and then you have your service and UI UX testing, and then calling it giving it specifically a UI UT unit testing. So these are the sort of very important aspects when you're bringing all these things together. So today the ecosystem is distributed. But I think it's super important to understand that eventually you need to have end-to-end service, and stitching and knitting these together takes time. Learning also takes time. We are learning as well on a constant basis. We've developed in our own methodologies, but it took us literally 2 years. So we're building our own toolbox, ML toolbox, in order to do that. And it takes time. And with customers, you learn the best, what they need. And this is how you build your pipeline. And I keep telling, and when I work also talk to founders of many of these MLOps tools. Many of these founders have raised millions of dollars. I just tell them what I have learned. So what I say is that don't go and build everything. Go to your customers and ask what they need, and just build that gold standard of MLOps, basically. And it could probably be 7 or 8 of these components that I need: unit testing, I need to have deployment, I need to have model registry, I need to have continuous monitoring as key sort of aspects. I need to be able to serve these into publish once and build once and publish anywhere sort of architecture. And then you can build out a great service, and there is a market for you, and you will be able to build huge revenues. So, I mean, that's the experience I have selling and working with enterprises. But again, I mean, just to give you a bit of a perspective on how to serve these models, so I'm just taking a small snippet. Time is, I don't have we don't have so much time. I know you guys are also getting impatient, like, oh, when is it going to end? So just giving you a small example of how to serve these. So REST APIs are, as you may have known, are super handy in actually serving your models and presenting into beautiful interfaces. Advantages are because they're isolated, so you can decouple your model development from client interfaces. They're super fast, so you can sort of serve predictions instantaneously to multiple clients. Where they're versatile, they can combine various models and API endpoints. And finally, importantly, is they're extensible. So you can scale by adding more instances to the applications behind the load banner. So you can actually scale these things as well. And Flask, just throwing an example briefly, is one of the tools. But again, like I said, there are many new tools emerging. We are building an app on Django, and eventually, for example, Live AI, we are building our own app as well. So it's going to be a platform that is shifting, and we are building it based on a machine learning model. So basically, we are teaching machine learning with a model that is learning machine learning. So that is something that we will release in the end of this year. So it's fascinating development going there. But again, I digress. But here you have alternatives like Django, Pyramid, Bottle, Streamlit, Netlify. So you can see here this field is also expanding. So it's very important to choose wisely. Okay, I think we're coming close to the deck, and I'll spend just a few seconds here. So this is how infrastructures stack up. If you're on the extreme left, then essentially you have your on-premise application. You do everything. You manage everything from networking all the way to the applications. And on the extreme right, you have your software as a service. And in the middle, you have infrastructure and platform as a service. I've just provided some examples, and I took this example from a website. BMC is a large company that actually first created this sort of simple idea for customers to understand, well, what is IaaS versus PaaS? And this used to be very confusing 10, 15 years ago. And here on the right, I've taken examples from another website called, I don't know, I think it's called Business MBA, and giving you an example of how you actually can deploy these, just to give you a bit of a high-level perspective. I think we are kind of close to now, actually just 2 slides left, and then we are done. So don't panic, because this is a fascinating topic, and my apologies if I extended it longer than an hour. But I think it's important to understand things from, as much as you understand things horizontally, you need to understand things also vertically. So how am I going to build my systems? Where am I going to build these, and how am I going to serve these systems? So this is an example from Docker website, and they were trying to show the difference. But I think I took some interesting sort of comparisons out of these, because I worked with hypervisors and virtualization for the last 2 decades, so I understand these from ground up. And these are very interesting comparisons. They say, for example, containers, as you have come to know, whether it's Kubernetes or Docker, are super fast, lightweight, reproducible. Makes a lot of sense. Yes, you can deploy these and because they deliver immutable infrastructure and actually solve the problem of it works on my physical box, and you deploy it elsewhere, and it just doesn't work. So that is amazing. Now people would say, okay, virtualization has also solved this problem, as you can see here on the image on the right. So you can have a physical machine, you have a virtualization layer, which is called hypervisor, and then you can build virtual machines. You can have a Windows machine next to a Linux machine, next to a Mac or some other machine, and you have application individually. And then there is a combination at the bottom. You can see that image where you can have, you can do a mix and match. Depending on what is the compute capacity do you have in your physical server, you can do any of these things. So for example, if you have less, go on the top right. If you have a little bit more moderate workloads, and you use virtual infrastructures as a practice, so a lot of companies on-premise infrastructures use virtualization infrastructures, so go with the top right image. And if you have large compute capacity, let's say you have a huge cluster of servers with few petabytes of memory and maybe a few petabytes of GPU, then it makes a lot of sense to set up maybe at the bottom left image. The key advantages are you can build once, deploy anywhere. That's wonderful. With virtual machines and containers, it works the same. You can seamlessly integrate into IT processes. And the difference between containers, where you can build a ton of containers on one machine, versus virtual machine, is the licensing costs, and things get expensive if you are doing things on virtual machine, unless you have a site-wide license. Think about that. And event management with containers is also much easier. So it's about your taste. And so think in terms of also what works best for you, and that'll help you actually kind of choose the right platform. Now here, this is what I was talking about in architectural choices. So what you see here is there are different ways to understand how and where I'm serving. Architectural choices just don't come simply because you have a lot of compute capacity. It also comes how you want to actually distribute your workloads to serve your customers. So if you want to do quick, sort of, on the fly, REST API like Flask, Django work a lot better. You can serve your models. So you can just see here on the graph. So training, you do batches, you serve in batches, or you do in streaming. So for example, uh, think of applications like Netflix. They do a ton of streaming. They don't do it in batches. Amazon as well, a lot of recommender sort of algorithm. There's a ton of streaming going on out there as well. Serving in batches works as well when you have shared databases, so you can actually do the serving on through the shared databases, so that way you can actually sort of focus on your workloads and actually serving your customers well. And then latency is as well an important issue. So for example, you need to have tremendously low latency when you are streaming, right? I mean, you understand that it's YouTube or any applications or your ML model which you have on an app or on or any other sort of web device. You need to make sure that your prediction should be instantaneous, and you're able to stream actually your prediction models and or prediction algorithms either through message queues, and there are some advantages but also disadvantages to that. And we've, with our teams, we keep working on this challenge as well. And then on an app, you basically are just having an in-process, essentially API on a smartphone. So basically, you're training by batch, you're predicting on the fly. You can serve through REST API. If you're training by batch, you want to predict by batch. You can serve through shared databases. And then you predict by streaming, or you train by batch, and essentially predicting on mobile or any other client. And then making sure, and obviously the bottom is most important. How do you manage these systems? So remember systems thinking. And then essentially you will see that it becomes extremely difficult. So that's why you need a large infrastructure when you're streaming, let's say, a large application like Netflix. So you need to have robust sort of systems management tools to do that. But in cases of shipping through REST API or for a smartphone, it's easy for you to actually serve either through batches or streaming. Cool. So essentially, the last picture, and I think then we are done with our conversation, and then I'll go back and sort of answer your questions, and hopefully you can ask more. My apologies, actually, if I read this monologue. So on the screen, I have the presentation, and my browser is on the other slide. So I'll open up and answer questions. So simplistically, and just so my advice to you would be is to continue to focus on understanding and deploying machine learning. Simplistically, think of gold standards. What is it that I need? So I need to build my model. I need to evaluate and experiment these. I need to put them into production. I need to test them. So these are important needs. These are not I don't need. So these are deployment is definitely, because that's where you're heading. You are heading towards production, right? That's where we all want to go. And then essentially, when you're there, then landing, and then you want to expand, meaning I want to be there. I want to understand how my server, my machine, how my models are performing. And that's where you're monitoring and observing your systems. So this is basically a short, nutshell kind of a conversation around MLOps. There are more stuff that I have here as examples, but I'm going to now go into my MLOps on my slide on the online streaming. Try to answer your questions. I really appreciate it. So maybe I can start answering what Radhakrishnan asking. Yes, it is through it is a batch, absolutely. So then I'm going to go up and try to answer. If there are any questions, I mean, please do ask questions and keep asking even after this online streaming or a live sort of webinar is over. I'm very, very happy to answer these questions. Like I said, MLOps is a huge field. Instead of getting overwhelmed, it's just constantly focusing on the key essentials that you need in order to ship your models from experimentation into production. As long as you keep those goals, you can actually, you don't have to get distracted with all the fancy tools that a lot of tools are building. They have their purpose, and they're super important. But just have the essential layer, and then you can focus on that. So let me just ask a question, Dilip. I'll just repeat your question. The only challenge I have is I'm unable to. Okay, that's a switch video to full screen. It isn't available on the mobile devices. Yeah, I think LinkedIn is still improving, Dilip. So I'm not sure how to make that happen. It's a bit of a problem. I think just like YouTube, I know we all gotten used to YouTube that you can do all kinds of theater mode and all that. I hope LinkedIn, I hope if you're listening, might be good to kind of take that feedback. Awesome. So there's, what else is here? So Purushotham has a question. So what are the limitations you see in university platform AI exposure compared to industry platform? I actually don't understand that question. In university platform AI exposure, I don't know what that means. So I'm going to pass. So yeah, I think Steve, you have you're sharing a point as well. Software crisis, take it to points through what are the parallels with that situation. That wasn't solved by a single technique, and I think that we can say the same, that it has been solved in practical terms. So will MLOps be part of a wider methodology? I really think MLOps is still going through its first wave of excitement and hype and all kinds of sort of experimentation. Or I foresee maybe 80% of the startups will either struggle because eventually you have to find and land your product inside enterprise computing or enterprise production workloads. That will also be defining in how well MLOps is going to further penetrate inside infrastructures. But I do believe that some companies will do definitely and dramatically well. I hope, at least, because that'll help all of us, further take our, this fascinating field of machine learning and deep learning into production systems. Because the big dream is that we need to work towards wonderful models, create great products. It's going to be a bit of a sort of head-banging exercise, Steve, if you ask me honestly, but I think it definitely is not going to be solved today. And I hope special interest groups, I think I actually compared this similar to how cloud computing was happening 15 years ago. There was a lot of confusion. People didn't know what cloud computing vendors would price. I also wrote a research paper back then working with all kinds of models. So pricing is an issue. I think the cost of technical debt or MLOps debt, we don't want enterprise customers to start paying a lot while they just use 5% of an MLOps pipeline in terms of the essentials that I keep repeating. So I think it's very important to have special interest groups and methodologies and practices that allow us to actually set standards of what it actually should be. Today, companies are setting up their own standards. Startups actually are doing wonderful things. So I think this needs to be done in order for this to be adopted in enterprises at scale. That's what I think. So Priyanka has a question. If we go for NLP as a major, then what should be our base, computer vision or text, which will be better and provide maximum numbers? Okay, so I think you're talking about major as in your education. If that is the if it's a question regarding your sort of taking up education, I think I would say try to focus on actually learning machine learning and specifically looking at the connectivity, the cross functionality between these two fields, computer vision or natural language processing or language models, and that'll help you well, Priyanka. I hope I understood your question well. So Joshi has a question. You're working industry as well. In working in data science, wanted to move to MLOps. What are the key things to learning operations? I think the tools are very simple, easy to understand. There are, in fact, go online and just download some trained models actually that people have already created and gracefully and graciously shared online on Kaggle and other platforms. Try to build your own pipelines, even if they are mini pipelines. Test these principles that I just shared with you. Hopefully, this will help you understand concepts of machine learning operations or MLOps. That'll really help you guys. Wonderful, Gopal. It's good to see you. Thank you so much. Happy to sort of have you guys here. I thank you, Subramaniam. I really appreciate. I actually, just to be, I was working till 4 a.m. On this slide, so I just wanted to do my best. I know I have to improve it. It's still, stuff in works. We are building our own stack. Actually, we're taking up. Slicing this whole MLOps life cycle into research ops, data ops, uh, model ops, and DevOps. So there is this huge infographic I'm building, and hopefully by the end of this month, I will share this as well in our training in Finland. I do want to obviously share something. Obviously, I should have done this because that's an important sales pitch I should have done. um, I believe it's. Anyways, I will share that with you guys in a few. Oh yeah, here I should share this. So you guys can sign up here. I'm just keeping this online. So cool. Toma, you have a question. I am a data scientist and I would like to learn about MLOps. I would appreciate advice where to get started. Toma, I think there's going to be, so if you just go on this link here already, you will see actually what I just explained is just the tip of the iceberg. But we are launching our MLOps course also in the next couple of weeks on Live AI platform. And it'll go through each and every aspect. So essentially, you can actually do a lot of things yourself. How to understand how do I do unit testing? How to create utilities? How to create sort of unit testing libraries? How to create registries in order to sort of build, save my models. So these are simple principles. What you see with the MLOps platforms today and all these companies that I shared with you, they actually also started off building these on simple open source platforms. So there many are still open sourced. My advice would be to actually, like I just said a few minutes ago, try to download a few models. Also, there's another thing I wanted to share with you guys. So this, do also take a look at, we teach our folks MLOps as well. So these are all projects, for example, we do teaching people on various disciplines. So I think the most important thing is to pick up a domain and train the data, build the model, basically do the basic simple steps essentially, and then you can have, for example, here you see examples of healthcare, agriculture, even HR. We have projects, climate AI, manufacturing. We just added a new project. So it'll give you a perspective. So as I just shared, remember I shared the slide in which showing that organization that it takes a village to serve ML model. I think if you focus on that, Toma, it'll definitely help you a lot. So basically, you focus into an industry. So you immerse yourself in understanding how you should work with that industry. What are the key things I need to understand? For example, this is about identifying welding defects in manufacturing. Looks like a simple problem. Use computer vision, look at welding defects, but it has huge implications. Imagine if there is a welding defect on planes, on airplanes, or large vehicles and large machines. So, and then converting that into a simple, very simple sort of MVP, have a model, test it, can I deploy it? Now, can I add another model or algorithm to it and see how it performs versus the first model and algorithm? So I have two, and now I have two models, as in that I can serve or deploy. So when you do these simple practices, that'll really help you understand the basic fundamentals. So that's how you get started, and slowly and step by step, you start learning about that thing. So cool. The prerequisites, excuse me. So there are no prerequisites, Raghu Prashad. You should understand machine learning and deep learning a little bit, but the whole idea is actually you learn everything in our MLOps course, because you will learn about software development, you will learn about infrastructure and engineering, and you will learn about machine learning. So I realize my throat is also getting a bit dry. I've spoken for 1 hour, 20 minutes. But if there are any questions, keep asking. I'm extremely grateful and thankful that you guys joined. I thank you with all my heart, and I hope to see you guys soon. Like I said, keep if you have any questions, go to our these links, and also try to see if you want to participate in this program. Go to this website. I have provided the links as well, and that'll help you sort of get an idea of what the course is going to be comprising of. So thank you very much, Bruna, Jamil, yes, agile methods. Last answer, pretty quickly answer. I think it's just simply basically agile methodology. Agile methodology, MLOps folks can learn a lot, and I hope that this is what I meant with standards and special interest groups. So we don't need to reinvent the wheel. Industry and enterprise customers don't have the time, and neither do you have the time if you're building an MLOps startup and raising capital. It's important for industry to come together, build standards, and then essentially serve these. So I think agile methodology, agile safe methodology, etc., are extremely cool to actually use. So once again, thank you very much. God bless you. I love you, and I hope you guys stay safe and stay safe with your family. And if you have a working day, I hope and wish you a wonderful working day. Take care. Bye bye.